We're back. Okay. All right. So I think we covered that. I think we got this package just about done. We've done this page. The only other thing I want you to try is right under the magic square. This question about the frog getting out of the well, this question was on a 4th grade New York State assessment. So what are the big years for assessment? 4th grade and 6th grade are big, right? I just remember my kids taking those in 4th grade and 6th grade. So this question, it's right under the magic square, was on a 4th grade. Look at the mathematical practice. It's modeling with mathematics. So go ahead and tell me how long it took the frog to get out of the well. And then I'm going to start giving you some new papers, okay? A bunch are going to come around, a whole mess of them, a whole slew of them. Okay. And I'm going to give you one, and then we'll start them with Victoria. There's one. A whole bunch are coming around. This is why I always tell you to bring a 3 ring. Oh, that's not good. That's just broke. 5 sections are going to come around. I'm just going to give them all to you so that we have them for next week. We won't cover all these, but we'll get there. They're in backwards order, because that's how printing services gave them to me. 6, 3. There's a bunch. So how long did it take for the froggy to get out of the well? Last one. Anyone do it? I definitely would draw a picture or table or chart or something. Picture, table, chart. A lot of people missed the coin question on the oh wow because they didn't organize themselves. So I'm looking at the problem right underneath the magic square. Joe, did you get it?
I think so.
What'd you get?
5 hours.
I don't know what the answer is. Anyone else get 5 hours? Oh, Jenny said it was 5 too. Yeah, so did Hannah. Bunch of people said 5 hours. It's able to crawl out of the well. So the answer key that they had for the New York State assessment is on this page, on the next page. This is the type of things they were hoping for. So 1 hour, 2 hour, 3 hour, 4 hour, 5 hours. So 5 hours he was able to crawl out of the well. So this was one where they reenacted how what happened to the frog. I like this one. This is probably how I would have done it on the number line. A chart would have been a nice way to diagram it. So after hour 1, where would have he been? After 1 hour, what would have his height have been? What would happen after 1 hour? Yeah, he'd be at 4. And then after hour 2, what happens? He slides back to 2. And then after hour 3, he's back up to 6. And then after hour 4, he slides back down to 4. I can put feet on here if that helps. And then after hour 5, he's what? At what height? 8 feet, and then he can crawl out. Do you see how easy it is if you draw a picture or just like a table or something to kind of reenact it? That was on a 4th grade math assessment. And that's what the key was in the back for the teachers when they were grading it. And then the last thing on this whole packet, and we're finally done with chapter 1. Go ahead and try this one. Dart problems are really popular. I have a bunch of them that my kids have brought home or parents have shared with me. Some are my kids, some are what parents have shared. Lots of dart problems. See if I can find one so that some parents have given me over the years. Joey's. I have a bunch of dart ones here. Show them to you. Can you get a 6? Yeah. What's the 6, Tilly? How do you do it? You can. You're right.
Oh, because he's throwing 3
4 darts.
or 4 darts.
Yeah. So how do you get a 6 if you throw 4 darts?
The 1, 3, and
Yeah, a 3, and then the rest of them have to be
the
ones. Perfect. Can you get a 10?
Yeah.
Yeah. How do you get the 10?
7 and then 3 1s.
7, 3 1s. Is there another way? 5, 3, 1, 1. Okay. Can you get a 13? How do you get a 13?
7, 3, 3 1. Oh wait, no, I'm just kidding. Oh my gosh.
Yeah, there's only 4 darts.
Sorry.
So Tilly started with a 7 and 3, but then shoot.
Yeah, no.
Can you get a 13?
No.
You say no? Okay, so we can get a 6. We can get a 10. Hannah said no on the 13. Can we get a 15?
Yeah.
How do we get the 15? How do we get the 15?
You could do a 7 and 5 and 3. Yeah.
But there's 4 darts.
Oh my god, I forget about that.
Yeah, there's 4 darts. Wait, 7 and 5 is 12.
Yeah, and then I was gonna say.
And then 2 1s would be 14.
Yeah.
So that won't work. 7 and 5 is 12. If you hit the 3, that, yeah.
You can't.
No, you can't. Okay. How about the 20? Yes. 28? Can you get any bigger than 28? No, that's the biggest one, right? Okay. So what's the smallest number that you can get? 4, right? All 4 darts. And the biggest value you can get is 28. Now, what did we cross off? I circled what's common with the ones that I circled and what's common with the ones that I crossed off. Evens and odds. All right, so this lesson in school, oh, here, I'll show you a couple. I have a bunch. So these are what their dart problems look like in school. Do you see the little darts? Yeah, I have a bunch of those, but we've seen one, they're pretty much similar. These problems in school are lessons on even and odds. It's not really dart questions, it's even and odds. So look, if you have all odd numbers and you throw 4 darts, if you add an odd plus an odd, what kind of number do you get? Even. So then if you have 4 odds, this is going to be an even. This is going to be an even. So what's an even plus an even? It always has to be an even. So there's no way you could get an odd number with throwing 4 darts. Now, if they talked about throwing 3 darts, what's the only number combinations we could get? Odd. Do you see it? So the dart questions are thinker questions, but they're really lessons on even versus odd in the papers parents have given me. So it says, predict what kinds of scores are possible. So what kind of scores are possible? Even between what number and what number? 4 and 28. And then, so is 18 possible? Yeah, that. It's an even number stuck between 4 and 28. You'll be able to find a combo for it. No odds. You can't get any combination for an odd number with four darts when they're all odd numbers you're adding. Right? So it's like a clever little way for kids to explore evens versus odds. All right, are we done with this packet? I think we've conquered all. So we will look at Pascal's triangle, because before we get out of here, we're going to come back to Pascal. But we can retire that packet, and then where did the extras go? Because I didn't get any.
Oh, there you go.
Yeah, I'm actually gonna hand them right back to you.
All right, here we go. So I'm going to go a little out of order with these, but we'll start with 6-1, because that makes the most sense.
I forgot, the only thing I changed, I wrote the answer down for this one. Everything else is.
Oh, you're allowed, sure. Okay, yeah. All right, oh, I don't want to lose this. Hold on. Let me put it over here in the folder. Okay. All right, so let's do a little bit of 6-1, and then we'll take a little break. I have to run over and look at a computer lab for someone, so I gotta walk over to the Shamong building really fast. And then we'll keep moving. All right, these questions. When I was looking through this, I just found one. Let's look at this. This is just like this. Draw the figure that comes next. Now, this is an old one. This is my son's paper. So, my kids went to Smith School, and they had Mr. Peck. I don't know if anyone went to Smith and had Mr. Peck. He was amazing. And talking with him, all three of my kids had him. And I asked him, I said, Mitch, what's a big challenge for you teaching 3rd grade? And you guys might find this too. He said, the biggest challenge he finds is the transition between subjects. Because when you're teaching 3rd grade, you're teaching everything, right? English, math, reading, history. And so he said it's hard he finds it hard to just shut off their brain from one subject and turn it on for another. So he had this book, it was really cute. It was called The Problem of the Day. And so when he knew he was transitioning, especially into math, he'd say, okay, let's do the next problem of the day. And this one was one of my kids brought home. It was the mystery square, right? A magic square was a problem of the day. And he said it gives the kids a chance to do some reading and just kind of sitting and thinking and pondering. And they don't necessarily have anything to do with the subject that they were going to learn that day, but it made them switch gears. And he said they loved them. Sometimes he would give them, Sudokus? How do you say it?
Sudoku.
Yeah, he'd give them like a real basic Sudoku just to kind of give them some, just to kind of like ramp down a little bit and then focus on some math. And this was a problem of the day. It's very similar to what we're going to be doing. It's sequencing, but with pictures instead of numbers. It's not hard. It's actually pretty easy because you guys are solid on patterns or getting solider on patterns. So this is called the L pattern. That might shock you. This is called the L pattern. All right. And so this is a homework question right out. All of these I just cut and pasted out of the book. Right? I should show you how to get on the book with WebAssign today, if I can remember. So they said, what are the number of blocks that'll be in the next figure? This is the first, this is the second, this is the third, this is the fourth, this is the fifth. So how many blocks? Can't see. Is it 12? Let's see. 1, 2, 3, 4. Here, I'm going to start. This has 1. This has 3. This has 5, 7, 6, 7, 8, 9. Did I count those right? Yeah. Okay, so what do you think? Now let's just check out the numbers. What do you think? 11. Does that make sense? What kind of sequence is this? Yes, it's arithmetic. Yep. So you're adding 2 each time. So how many blocks would be in the sixth figure? 11. The nth figure, now if you didn't do it on this, oh wow, I won't mark wrong, but they will mark it wrong on the final because we do group grading. So on the final, this is not going to get you full credit. On the final, you got to fill in the A and the D. The only thing that should be missing is the N. So what's the A? 1, perfect. N minus 1, and then what's the D? 2. I'm thrilled if you leave it like that. I would never take off in a million years, but only because I saw how they left the answer on that old certification exam. Let's just practice simplifying it, because I have a feeling that's probably on the certification exam, right? That I just ordered that book over the summer, so that is as new as it comes. So just to practice, right, to get rid of the parentheses. This is lovely for me, but just to practice. To get rid of the parentheses, if you're doing it on the certification exam, we're going to distribute the 2. Perfect. And then,
You can add the 1 and then minus 2. So
Yeah.
you get -1.
yeah, so this is what the certification exam would have as one of the multiple choices. So we'll just keep kind of rolling with that so that we're comfortable. I want you guys to rock that exam. We okay so far? Any one of these, I don't care for me, answer it this way, this way, this way, I don't care. But I just noticed that that's how they answered it on the exam. Okay, so now we could do the 6-figure, 7-figure, 8-figure. If we kept making this L shape 355 times, how many shapes would there be? What do we do with the 355?
Plug it in for N.
Yeah, perfect. Substitute it in, plug it in for N. And then just pull out your calculator. I thought I brought one. Here's my phone. Oh, it was in the box. I'm normally not this scattered, but I've taught 6 hours this morning, so I'm tired. So you have to pardon me. But Hannah, tell them, aren't you glad you have me, Hannah, instead of the other person you had, right?
Yeah.
See? I don't know him, so I'm sure he's lovely, but
I don't really even think he's here anymore because I was scheduled to take this class again with him, and then like the last 2 weeks I got moved
yeah, to who?
with you.
Yeah, to me. Uh-huh. Yeah. So it's a little surprise that I was teaching this. 709? Do you guys get it? You good? All right. This is another one out of the book. So, and this was a pattern on the, oh wow, I just gave back. So first figure, second figure, third figure, fourth figure, fifth figure, sixth figure. Okay. What do you think? 1 has 1. Second figure has 4 blocks. Third figure has 9 blocks. 4, if you count those up, that's 16. How do we connect those? It's not arithmetic, not geometric. What is it, Sean? N squared. Do you see you take the position and you just square it to get the number of dots? This is actually, just as an aside, why these numbers are called perfect squares. So like if I wrote, here, let me pull out an old wow, or someone that wasn't here. Let me pull out their wow. There's a couple people not here today. Let me show you. It's interesting why these numbers are called the perfect squares. They're not called the perfect squares because of the 2. They're called the perfect squares because they make a square when you orient them. Like you can't orient 26 dots and make a perfect square. But you see you can orient 25. It's a 5 by 5. And it's a perfect square. Do you see that? That's why these numbers, 1, 4, 9, 16, 25, these are called perfect squares because you can orient them to make a perfect square. Do you see it? That's kind of cool, right? So what Sean said, it's whatever position you're in squared. So if I had to be the 6th position, how many dots would I have? 36 dots. It would be a 6 by 6. Now let's look. 2 by 2. Do you see it? 3 by 3, 4 by 4, 5 times 5, 6 by 6. You with me? Okay, so this would be 36 dots. So the nth figure would be n squared, right? And then the 90th figure is just what? Perfect, 90 squared. 90 by 90, or 8100. So on the oh wow, that was one of the sequences. 1, 4, 9, 16, 25. And the pattern was just you squared whatever the position you were in. Just if you want to look at your oh wow I just gave back, that was one of the answers. A couple people missed that one. I don't see any old oh wows. I don't know. I'll find them during break. We okay? All right. So you guys try the toothpick problem. Okay, go ahead and try it. How many would be in the fourth? I didn't make this up. This is right out of your book. How many for the nth? Simplify it like they did in the certification exam. And then the 300th. Might not shock you that they call that the H pattern. Let me find your oh wow. Here's one. Person left it blank, which makes me so sad. Boy, this video is lasting a long time. That's good. Simplify it out, just like the certification exam. You don't have to do it for me, but I know you have that ahead of you at some point. I want you to be able to do really well on it. Everyone in here will take that eventually, right? Yeah. The certification exam through K through 6.
I think you even have to take it at the gym, like even if you're going for like to be a phys ed teacher, you still have to take the certification.
Oh, really? Oh, I didn't know that. Julie is the master of all things that, so she just asked if I could try to start reviewing for you. I said, sure. I don't know, but I'll try. Do you want me to take this for
Oh, yes.
All right, Allie, let me see. It's not in here. It's Allie, right? Da-da-da. Oh, I know why. Because you didn't have your last name on it, so I wasn't sure. Hold on. Let me take a picture of it so I won't forget. That's okay. I think I have an Allison in my other class too, so I put them both together. What's your last name? Just so I make sure. Yep, Miss Lupton. So this is yours. I'm glad you said something. All right, what'd you guys get? How many? All right, well, how many in the first figure? How many toothpicks? 5. And then the next one? 8. And then the next one? So right there, that should be enough to go, oh, I can already tell you without even drawing it how much is in the fourth figure. 14. Good. Does everyone see that it's arithmetic? Okay. So arithmetic, here's the formula you have to memorize. Now let's fill in the A and the D. So A is 5, right? And what are we adding each time? 3. But that wasn't a choice on the certification exam, so they wanted you to simplify it. So we'll distribute through the 3. And then combine like terms. So 3n plus, do you guys get 3n plus 2? Okay, but any one of these will do, as long as you, like, this is fine, this is fine, this is fine for me. And then the 300th, so you just pop in 300 for n. So what'd you guys get? 902. So that's not so bad, right? We okay? All right, try the pentagon one. Oh, sorry, I took this off of last semester's final. If you ever see a point allotment, do you remember I said I was just going to use last semester's final for? That's because that came off the final. Sorry, I thought the point allotment. I try to remember to take it off. That was off last semester's final because I see the point allotment on it. Remember, perimeter's just the outside. Just looking at the outside, not the inside at all. Just the outside box. Like, this is the perimeters, just the outside boxes. You ignore the inside. Perimeters of a polygon are just the outside boxes. The number of sides on the outside. Oh, this is similar to the upstairs one, isn't it?
This was,
Huh, I just cut and pasted it from the final. I didn't know what it was. I didn't remember. So what'd you guys get for the fifth? 17. I didn't know it was going to be exactly the same. I'm going to redo it, but you probably don't have to. It would have been 5 plus n minus 1 times 3. Just happened to be the same as the upstairs. That was fluky. I'll go ahead and distribute just for kicks. Is that okay? Okay. And then for the 100th, what do we do with the 100? Yeah, plug it in for n. Perfect. 100 plus 2. So you guys get 302 for the perimeter? We do okay? It's not too bad. Definitely will have these on the part 2 on the test and on the final. You have something similar to this. All right, let's see how you do on the next one. We'll do like 2 more and then we'll take a break. So I have to run over and look at a computer lab for a friend. See how many seats are available in it. Okay, we ready? I did this in color so that you could see it. You could tell this is out of the book. So it says you're designing a square patio using blue and green tiles. How many blue tiles and green tiles will be used in the next patio? So it's not all arithmetic or not all geometric. I'm hoping you start to recognize this pattern. So fill in for the blue tiles for the 4th figure, the 5th figure, the pattern in words, the 20th figure, and the nth figure. And then do the same thing for the green. And then you just add them together. Then you put a big plus. I mean, if you needed to know the total number of tiles. And then we'll do this one, and then we'll take a break, the one on the bottom. It's a beast. It's a beastie. We doing okay? Doing the blue, then the green. I mean, just do them separate. It's working hard. It's great. Did you get it, Vicki? Or Victoria? Which one are you working on? The blue?
Kind of did a little bit of all of it.
Okay, so let's just ignore the green and look at the blue. So for the first patio, like the mini patio, patio number 1, how many blues were there? 1. Okay, so 1 gets mapped to 1. For the second pattern in the patio, how many blues are there? 4. So 2 gets mapped to 4. In the third patio number, how many blues are there? Do you see them? How many are there? 9. What's the shape called? What's the special word for these shapes? Squares. Okay. So in the fourth patio, if this pattern were growing, how many blue tiles would there be? What do y'all think? 16. It would be 4 by 4, which would be 16. You getting it? So in the fifth pattern, what do we got? 25. Perfect. So what are we doing? Like, describe it to me in words. We're taking the patio pattern, like the position of the pattern we're in, and squaring it. Perfect. So we just take the patio number and square it. So for the 20th patio, what would be the blue? How many blue squares? Yeah, how'd you get it, Sean? 20 squared. So then just in general, in terms of n, like on the certification exam, they just what n squared. That's for the blue. We good? Do you see it now? Here, let me show you an oh wow. That pattern was on the oh wow that I gave back. I have one right here. Let's find someone here. This person didn't fare too well on his oh wow. Yeah, I don't know what he's doing. This is a heartbreaker. So right here, let's look at his. So one, do you see these are perfect squares? Right? So the first number is 1 squared, 2 squared, 3 squared, 4 squared. So this would have been 5 squared. You with me on that one? So then the 20th term would have just been 20 squared. You okay? You with me? Cubes are very popular too. I'm going to write on the back. I noticed this is one in WebAssign. Here, I'm going to write this. That's a popular one. Do you see they're not perfect squares? It's not arithmetic, it's not geometric. Do you see those are all perfect cubes? Do you see that? Those are really popular as well. You'll see those in the homework and on website. I didn't put that one on in a while, but that will definitely be a good test option. So if this is the pattern, do you see it's 1 cubed, 2 cubed, 3 cubed. I don't know. I think 4 cubed is 81. I was just taking a stab at that. Yeah. No, I'm sorry. It's not. 4 cubed. Oh, I'm so sorry. It's 64. I shouldn't do it in my head. That's probably why Victoria looked confused. So then this would have been 5 cubed, would be the next one in the pattern. So what's 5 cubed? 125. And the nth term would have been n cubed. Is that okay? Sorry about that. Anywho, okay. All right, so now let's do the green. So the first term has 8 in it. And what happens? Do you see the pattern?
Goes up 3.
Yeah, goes up how many each time?
4, gosh.
Yep, plus 4. Do you see that? Plus 4. So the nth term's gonna have, I'm sorry, the fourth term will have 20 greens. Then the fifth one will have 24. So the pattern in words is you're adding 4. So let's get it down in n first, and then we'll work our way backwards. So in n terms, it's the first term plus n minus 1 times, what are we adding each time? 4. So let's do it the way the certification exam does it. So 8 plus 4n minus 4. And then if we combine like terms, 8 minus 4 would just be plus 4. Are you with me on that one? So now for the 20th term, how many green tiles would we need? For the 20th? Yeah, so 20 times 4 is 80 plus 4. 84 green tiles. What do you think? You okay? All right, let's take a break. Because this one's a really long one. This one. It's super long. So let's take a break. I just need to run over to the Chemung building to look at a lab that's over there, and then I'll be right back. So I'm going to leave my mess here. And let me pause this. I hate to turn it off because I'm so worried it won't come back on.